Hello, welcome to lesson 10.3, independent and dependent events. So in this lesson, we are looking at independent and dependent events, and let's describe what each of those mean. So two events are independent when the occurrence of one does not affect the other. So for example, in this first one, there's a bag of marbles, a marble is taken out, but it's put back in. Since all marbles are still in the bag, the outcomes do not change. And actually, let's highlight that. Independent events are ones that one event does not affect the other. But they are dependent if the occurrence of one event does affect the other. So for example, I take a marble out of a bag, I place it on the counter and draw another marble out. So that means the marble is taken out and left out. This affects the bag now. There's one less marble in the bag, so there are different outcomes. So independent means basically the outcomes do not change. And with dependent, the outcomes do change, so they're going to be different. Okay, so let's look at example number 1. So you select a card from a standard shuffle deck of 52 cards. You return the card, shuffle, and then select another card. Both times the card is a diamond. So we're just determining whether it's independent or dependent. We're not solving anything yet. It says you select the card, you return the card, okay? When you return the card, that means, are the outcomes changing? No, it's going to start with 52 cards, and then the next event's also going to have 52 cards. So this is independent. So basically, if you put something back, it's pretty much going to be independent. If you take it out and leave it out, then it's going to be dependent. Okay, so for number 2, a box of chocolates contains 6 milk chocolates and 8 dark chocolates. You randomly pick a chocolate and eat it. Then you randomly pick another piece. Both pieces are milk chocolate. So this key word here is, let's see, and eat it. There we go. So if we pick the chocolate and we eat it, we're not returning it back to the box. It's now in our stomach. So therefore, this is going to be dependent. See, because the number of chocolates has changed now. If you've eaten one, you have one less now. So with that being said, go ahead and pause the video and read 3 and 4 on your own and try 3 and 4. All right, so for number 3, a basket contains 5 apples, 5 peaches, and 5 pears. Randomly select and eat 3 pieces of fruit, and so on and so forth. So you're eating the pieces of fruit. So again, if you're eating something, that means you're taking it and you're not putting it back. That means it's going to be dependent, because now you're going to have less pieces of fruit the next time, the next event. For number 4, a spinner has an equal chance of landing on each of its 4 number regions. You spin 3 times. And so again, are you changing anything? So with a spinner, you're not taking anything or putting it back, but you just, every time you spin the spinner, have those regions, or like the areas of the spinner, have they changed? No, they have not, right? So if there's no changing, it's going to be independent. Okay, so let's go on to the back, which is now we're going to actually solve. And so to find the probability of 2 independent events, we're going to multiply the probability of each event. So let's highlight that. So independent events, we're going to multiply the probability of each event. And then with 2 dependent events, okay, so if they're dependent, we're still going to multiply the probability of each event, but we're going to make sure to account for the different outcomes. And so I'll go over each of these. Or actually, we don't need to go over these. Let's go ahead and do the examples, and you can read these later. Yeah. So for number 5, you flip a coin twice. The first flip lands tails up, and the second flip lands heads up. So we want to still, just to reference this, we want us to identify the events, just like we did with the last lesson. So what are my 2 events? Well, I'm flipping a coin twice, so it would be flip number 1, and it would be flip number 2. And in the last lesson, I just said, let's, write down the number of outcomes. This time, you need to have a fraction, right? So again, referencing this example box, you need to have a fraction. The top is going to be what the question is referencing. So like the first coin is a nickel, so the top one is a nickel out of the total. The second coin is a dime, so the second event is going to be dimes out of total, and so on and so forth. So when you flip a coin twice, the first flip lands tails up. That's what we're going to write. So tails up, or just tails, over the total. And then our second flip, it says the second flip lands heads up. So it's going to be heads over total. And now we have to put in numbers, basically how many outcomes when you're flipping a coin would have tails, right? How many sides of the coin has tails? Just one. Out of how many total outcomes you have for flipping a coin, that's two, right? Heads and tails. And then same thing for heads, right? If you have heads, that is 1 out of 2 sides. So you have 1/2 times 1/2, which is 1/4. Now on the practice, it's going to be decimals. So just get used to changing fractions to decimals, which means you take the calculator and you just put in 1 divided by 4, which we hopefully know is 0.25. All right, and that is number 5. So now number 6, the way we did this, or the way I did this, is you kind of actually do have to go over these examples first. So actually, let me go over this example here at the bottom, the sock drawer one, and then you can try number 6, because so number 5 was independent. When you flip a coin, it's just independent. But number 6 is going to be dependent. So let's look at that. So it says example. So I'm looking up here. You guys can't see that up here. There we go. Your sock drawer has 2 white socks, 4 brown socks, and 4 black socks. You pick a sock for your left foot and then pick another for your right foot. You leave with a white sock on your left foot and a brown sock on your right foot. So basically, is this independent or dependent? Because you're taking a sock out of the drawer and not putting it back, this is dependent. So that means your first event, right, your left foot was a white sock. So that would be 2. There's 2 out of a total of 10 socks. So you start with 2 out of 10. And then your right foot, what I mean by taking account for it is that basically, well, it says brown socks. So your top is going to be 4 brown, right? 4 brown socks. But then the bottom, your total is now 9 because 1 is gone. 1 is now already on your left foot. So instead of 10, you have a total of 9, and then you're going to multiply. And so that's how you get your answer for if it's dependent. So go ahead and try number 6. You can pause the video and try it on your own now. All right, so there are 5 boys and 7 girls in the class. The teacher randomly selects one student to answer a question. Later, the student randomly selects a different student. The first student is a boy, the second student is a girl. So our events are picking the students. So we're going to do student 1 and student 2. That dot means we're going to multiply. So the first student is a boy. Okay, so that means we're going to put boy over total. And the second student is a girl, so we're going to put girl over total. Okay, so the first part is just deconstructing the question. Then, okay, how many boys are in the class? It says there's 5 out of a total of how many kids are in the class. It must be 12 because 5 and 7 is 12. And now the second event with the girls, how many girls? There's 7. But now the total has changed because they are selecting a different student, right? A different student that makes it dependent. That means instead of 12, right, you don't have 12 to choose from, you have 11 students to choose from now. And then we're going to multiply. So we're going to take our calculator. So 5 times 7 is 35. And 12 times 11 is 132. Okay. And we're going to divide 35 by 132. And we get, so we could, let's just write the decimal. So 0.265. In the practice, they're going to all be as the thousandths place. All right. So now we've got 2 more. We got 7 and 8. Now the difference between all of these, the front of the page is just determining is it independent or dependent. 5 and 6, there are just 2 events, and I believe with 7 and 8, there are 3 events. So that's the difference. Sometimes you'll have 2, sometimes you'll have 3, but no more than 3 in these questions. Okay. All All right, so for number 7, a basket contains 4 apples and 6 peaches. 3 times you randomly select a piece of fruit, you return it to the basket, and then you mix up the fruit. All 3 times the fruit is an apple. So this, because you're returning the fruit to the basket, you're not eating it, this is independent. So you're just going to be multiplying. We don't have to account for anything. And it says 3 times you pick fruit. So it's going to be fruit number 1, fruit number 2, and fruit number 3. And the first time it says, well, all times you get an apple. So we can just put apple over total for all 3 times. And if you're getting the hang of this, you don't really have to write these words, but I would still, write down on paper at least the fractions that you should be getting. So an apple over total would be, so how many apples? It says there's 4 apples. And how many total pieces of fruit? 4 plus 6 is 10, so there's 10 pieces of fruit. And it's the same thing for each time, 4 out of 10 for all 3 events. Because again, you return the fruit to the basket. You're not eating anything. Okay, so it's 4 out of 10 times 3. So 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. And then 10 times 10 is 100. Times 10 is 1,000. And when you put this into a calculator, you get 64 thousandths, which is 0.064. And I ran into number 8. But go ahead, see if you can at least set up number 8 and go ahead and solve it too. And we'll see if you're right. Okay, hopefully you tried it. Remember, I know the video is tempting to just kind of go through, but you should really be pausing and trying it. That's why there's always more time than the length of the video to do these. But anyway, okay, so a cooler contains 11 bottles of sports drink. You randomly grab a bottle for your coach, your friend, yourself, right? So since you're not returning the bottles to the cooler, right, this is dependent, right? You're keeping a bottle each time. So our first one is, so your coach and let's write, how should we word this? We'll put our coach, our friend, and ourselves. Okay, those are the events. So if your coach gets an orange, we're going to put orange over total. If your friend gets an orange, we're going to put orange over total. And for yourself, you get fruit punch, so you're going to put fruit punch over total. Let me just pause here and make sure. I know I've kind of went quickly through this wording part, but this part is so important. So where am I getting these words? So the coach, the friend, and the self, those are the events. Basically, you have to ask yourself, what is happening? And it's saying you're picking bottles for your coach, your friend, and yourself. That's where the first words come from, are just what's happening in the question. Then once you've identified the event, then you have to say, okay, if it's kind of telling you your coach is getting an orange, then it should be orange over total, or whatever it is. It could be a brown sock over total, or getting heads over total. It's whatever it's telling you in the question, like find the probability of your coach getting an orange. So that orange needs to go on top, and total always goes on the bottom. Okay, so hopefully I've clarified that. All right, so now orange. How many are orange? 4. So there's 4 orange. And there's 11 bottles total. That is when you pick for your coach first. Now for your friend, there's how many are left in there, right? If we've already gotten an orange for our coach, right? There are 3 orange left that we can choose from, right? And then what's our total? It's not 11 because there's already one that we picked for our coach. So there would be 10 left, okay? So see how, like, the first event, it's 4. There's 4 bottles out of 11. So 4 out of 11, just picking an orange, right? Now that orange has been picked, there's 1 less orange in the cooler, and there's 1 less bottle in the cooler. So that's where I'm getting that 3/10 from. And then the fruit punch, there are 4 fruit punch. And now there's a total of how many bottles? 9. Okay, so make sure you've accounted for those. Let's see how the numbers are changing because it's dependent. Okay. And so now we have 4 times 3, which is 12, times 4 is 48. And then 11, let's do 11 and 9 first, which is 99, times 10 is 990. So let's make this into a decimal. Hopefully I can write. All right, so 48 divided by 990 equals 0.048. Okay, we're gonna round it to the nearest thousandth. Okay? All right, this is a long video, 15 minutes, but hopefully we understood. If we did not, please come and find me and I will help you. Otherwise, I will see you in the next lesson. Bye.